I'll be performing a no AI study for the chemistry subject. So let's open the document first. So the instruction states that I have to give a p-test for 20 minutes. So I'll set a timer for that. I have to take a break and then I have to self-study for 60 minutes and then give a post-test. Alright, so I'll have to go for the whole thing for the chemistry subject. So I'll open the chemistry topic. I'll just check the row if this is correct. So and again recheck that I have to give this test for only 20 minutes. So I'll set a timer. Alright, so 20 minutes. So this is starting. I'll record this, and the first question states that I have to look at this diagram here. It looks something like the benzene ring, which I have studied before, and I have to answer some questions. So there are dash carbon atoms in the parent chain. It is called. So I believe this outer lines will be the parent chain. I'll just increase the size of the screen here. So there will be carbon atom at every edge of this ring. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so if I remove these things, let's count again. 1, 2, 4, 5, 6, 7, 8, 9. I'll go with 9 then. 9 means non, 10 means tech. Numbering of these molecules will begin at carbon. Okay, that's tricky for me. There are only 4 options: alpha, beta, delta, gamma, epsilon. Alpha, beta, delta, alpha, beta, delta, epsilon. Okay. I'll go with beta, but I'm not sure why. Sorry. Now use this information along with the previous diagram to answer the following 5 questions. Consider for the possible branches at carbon XYZ. So I'm hoping that there will be like more additional carbons at XYZ. The branch at carbon Y will be called Y. So if I add something called CH3 here, that's like a carbon needs to have 4 valence bonds to be balanced. So this will be okay. So it will be methyl, carbonate Y, methyl, CH3. Methyl is okay. Let me add Y. So there are 3 bonds here. So that the carbon here will only be C. So I'll go with propyl because there will be only a single carbon atom there. All the 4 bonds are occupied now. Which carbons can only make one bond? X, Y, X, Z, or Y, Z. X, Y, X, Y. X has 2. It has CH2 here. So X can make. What about Y? Y has 2 CH. If I assume that Y already has, okay, so it's they all got carbons X, Y, and Z. So X can make. If Y got one more, so 1, 2, 3 Y. What about Z? So all 3 have, if all of them get 1 carbon, so all of them will get something like CH3. So 1, 2, 3, 1, 2, 3, 3. So all of them can make according to me. Which carbon is able to make 2 more bonds, X, Y, and Z? I don't think so, anyone. Because they already have one. IUPAC name, I can't even. I just know that there's something called benzene rings. The addition of a methyl group onto carbon dash would add an extra side chain. A methyl group, a side chain. What is a side chain? Alpha, beta, alpha, gamma, delta, epsilon, delta, tau. Alpha, beta, alpha, gamma, alpha, beta, alpha. I'll guess it. I don't know. Let's go with alpha, beta. Sorry. Okay, something happened. Let's try. Oh, okay. Nothing's lost. I'll just see if this is an issue with the screen thing. Now, which of the following molecule is not an organic molecule? Methoxide, CHCl3, carbon dioxide. Carbon dioxide is not an organic molecule. Methoxide. How many valence electrons are present in methane? Methane, CH3. So, methane is CH4. Alright, so methane is CH4. So at every hydrogen there is 2. So I'll go with 8. Which element has the same number of electrons as methane has valence electrons? Carbon has 4. That's why oxygen has 8, I guess. Neon, hydrogen, helium. Alright, I'll go with this one. Which of the four functional groups are most likely to taste sour? Okay, so I don't know that COH. I'm not sure what CR dash is, but I'll go with COH. Can you answer to the previous question? Participate in hydrogen bonding. Can you answer to the previous question? Participate in hydrogen. I'm not sure which molecule will have the lowest boiling point. The molecule which is more easier to break, I guess. So I think oxygen molecules form double bonds, so they're very strong. I guess CH3Cl. I'll guess either CH4 or CH3Cl. I'll go with CH4. How many hydrogen atom does an alkane with N? Hydrogen atom does N carbon has? An atom does an alkane. There are I have 3 carbon atoms forming a chain. So there will be 3 on the first one, 2 on the second, and 3. 3 plus 3, 6, 7, 8. 3, 2, 6, 7. I'll go with 2 and plus 2 then. You can get that. Alright. Use this information to answer the following 5 questions. Molecule name is given. The boiling point is given. Okay. Which molecule can partake in dipole-dipole interaction? Dipole-dipole interaction, whatever has a valence bond. So, H2O. C5H9. Yes. I'll go with the last 2. One methanoic and decanoic. Diethyl ether. Alright, I'll go with C. Assume each substance is a liquid. at a room temperature. Which of the molecules can mix with CF4? Oh, okay. F is fluoride. So diethyl ether. F. I'll have to take a guess. I'll go with methanoic acid. Why can they mix? I have no idea. Despite the methanoic acid has much fewer carbon atoms than methyl cyclopentate. Despite that, methanoic has fewer carbon atoms than methyl cyclopentate. Its boiling point is much higher. Participant. I'll go with oxygen because oxygen increases the strength of the bond, and that's. Would you propanol to be placed? Propanol. I don't know what propanol is. I'll go with A. Use this diagram to answer the following 4 questions. The addition to which would not produce a molecule with a side chain. To which carbon? So where if I add a carbon molecule, will it leads to its side chain? So if I add a CH3 here, it will not lead to a side chain. What about beta? No, and this gamma. So I'll go. Okay, I'll go with all of them. The addition of a methyl to which carbon would produce the same molecule, alpha. Yeah, I think if I added everywhere, how many valence electrons are present? So I have a C here, 1 2 CH2 1 2. So there will be 2 bonds here, 2 4 6 7 8 16. Okay, so here I have another carbon with an H, and I'll have 1 2 3. I'll go with 6. Propyl group, methyl meth is 1. Okay, the propyl is I think C2H5. Propyl groups can be added to carbon alpha. Alpha already has 2, I think 1. It's 1. The electrons are not fixed. This is called they are conjugated. It's a process called conjugation. Let's write conjugate. If I'm correct, they make a ring around that. I'm not sure about the name there. A neutral dye has been discovered as polar. It does not have any natural order or color without the presence of another chemical. In the lab, you are presented with 5 vials that may contain the compound. It's polar. How will you add orange? The artificial will absorb into the compound. Titrate using its CL decreases. This present titrate using it will neutral. So it's a polar molecule. That's the only statement that talks about the polar nature. Alright, so let's see the score. I got 11. I was not expecting that. It will begin at epsilon. Okay, I was thinking that it should be at either end. That's why I went with beta. Alright, so the branches are called methyl ethyl. Oh, okay. Y and Z. The addition of a methyl group into carbon and would add an extra. Which of the not one? I am writing that. How many valence electrons are present? Which of the same number of methane has? Correct. Yes, I was writing that. There's a hydrogen bond. Can you answer the previous question in hydrogen bonding? There's a hydrogen bond. Oh, it was just asking about that. Okay, this is my bad. Yes, I was correct about the OH thing. How many? Yeah. So, which molecules can part? That was a guess from my side. I had what? Why can they mix with CF4? Methyl has only one. I am not sure what this. But methanoic acid has oxygen atom. Oxygen atom increases the boiling point. Carbon would not produce. Yes. Electrons. I got that one wrong. Well, oh, so okay. No, this is supposed. It got auto corrected, but it's delocalized. Yes, that's the right word. It's in conjugation. Yes. So I did the first part. So I'll just stop. I should have stopped the timer before. Right. So let's see what the next instructions say. So I have to take a pretest. I have to take a break for 5 minutes. Okay. And then study for 60 minutes. So I'll take a break for 5 minutes. And then I'll be preparing for the next 60 minutes. Alright, I only have few seconds left, so I think I can start now. So I'll just stop the timer. I'll go back to my scores, the chemistry paper. So I'll start looking for that. So I will split my screen into two regions. So just there. Right. So I have to give 1 hour for the learning part. What I'll do is I'll have to take a screenshot of this, but I'm not able to because I'm recording. Right. So let's see if this allows me to get something out. I think it's going to be difficult for me to create a screenshot here. So let's start asking the question based. So on this, how does numbering of the molecule starts in a organic molecule with multiple rings without AI. Alright, ring bonds. Naming bicyclic. Okay, this thing, this will take me to a video. Count the number of carbon atoms of the full bicyclic and determine the name using the prefixes. This is full ring in the name. Okay, I'm not understanding this part, but let's go to the second point. Count the number of atoms that are only part of a larger ring. If both rings are present, select one of the two rings. This is the X name. Count the number of atoms that are only part of the smaller ring. Count the number of atoms that are bridged. I think I need a page with better understanding. Yes, this video is a better choice, but I would rather like naming bicyclic compounds. What would really help is something with an example. Yeah, so before we start talking about bicyclic, let's go over terminology. Bicyclic are a specific kind of polycyclic compounds classified as compounds that contain more than one ring with at least two common atoms. So they have at least two common atoms here. Right. The common atoms connecting the rings in a bicyclic are called bridgehead carbons. Bicyclic are turned divided into fused and bridge cyclic bicyclic. It's fused when the bridged carbons are adjacent. Fused. Okay, there are two kinds. So in bridge bicyclic, the joint carbons are further apart, and when they are next to each other, we have fused bicyclo compound. Alright. The first rule is to start numbering for one of the bridgehead carbon atoms. So the bridgehead. What if I have two bridgeheads? So are there any two which is common? No. So remember the rings are numbered according to the size. So here we'll go clockwise, numbering the ring on the right and one on the left. You wonder why I call them a ring on the right and a ring on the instead of cyclohexane and cyclopentane. The reason is that they're not actually two rings, rather a whole structure with 7 carbon atoms. Okay, so what I'll do is, no, I can't take that. This numbering in the brackets are shown. This is really I'll keep this question for the last. Okay, so let's go with Can you answer to the previous participant in hydrogen bonding? Why? Participant in hydrogen bonding. Alright, this was pretty straightforward. I guess the question asked whether this group, what I would like to know is carboxylic acids. Which of the following is the answer? But this is just asking us to give the answer. Okay, so functional complete. The sulfonic and the carboxylic are the strongest acids. Many of them behave as weaker. A functional group is an acid. It can donate a proton to a base. It can donate a proton. Here's a list of functional group alongside with the pKa value. Okay. In the industry, SO3 sulfonic acids, PO4 phosphoric acids, carboxylic acids, thiols. Bonds can behave as the pK value ranges from depending on the groups. Alright, so this is not the only one. If there was a pK, PO4, H4 type of atoms, there was 3 sulfonic kinds, thiols. Alright. Which molecules can partake in dipole-dipole interactions? So wherever there is an oxygen, that's what my assumption was. Assume each substance is a liquid at room temperature. So let's put this one like this. This can mix with ethanoic acid. Okay, this is very taxing. It's very difficult to. Let's frame this question like that. What kind of organic molecules can mix with CF4? CF4 is a molecule with covalent, not an ionic. Okay. Please. I'll go with this page. I hope this has some. It'll tell me something about the nature of the bonds here that will help us. Twice methyls. Okay, let's write like this rather than Y. Can mix with CF4. This is very difficult here. I'm not finding anything. I don't want the images. I want methyl. What do you mean? Yes, let's go with that. Influence of water insoluble organic CC. Compound X has the formula X3X. So compound is the formula X3X is 1 mole of hydrogen. So let's off it. Alright, medical guide compilation. You're asking in relation to homework, can you do the list of basic properties? I'll go with Quran because I'm not finding anything useful on the website. Can someone give me one example of molecules belonging to 4, 5, 6? It's too tricky for me. There's the indication of kind of symmetry a molecule have. Hydrogen, water has point C2. Okay. Which of these molecules? Assume that it's a liquid. So methanoic. Okay, what I'll do is methanoic. No, sorry, methyl cyclopentane. I'll look at the structure. Maybe I'll have an idea there. Right. So methyl is an organic compound with CH3CF5H9. It's a colorful, flammable liquid with a faint odor. It's a component of the naphthalene fraction of petroleum mixed with cyclohexane. Excuse me. Methyl was first synthesized by. So I'll have this thing. Methyl has London dispersion. Methyl cyclopentane only has London dispersion forces. Like disolcipher also has. Okay, so it's better if I should have started with this. London dispersion forces, LDF. London forces, instantaneous dipole-induced dipole forces, fluctuating induced dipole, or loosely as van der Waals, are a type of intermolecular forces acting between atoms and molecules that are normally electrically symmetric. That is, the electrons are symmetrically distributed with respect to their part of van der Waals forces. The LDF is named after German Fritz London. The electron distribution around an atom or molecule undergoes fluctuations in time. Alright, these fluctuations create instantaneous electric fields which are felt by the nearby atoms and molecules, which can adjust their distribution, especially of their own electrons. The net effect is that fluctuations in electron position induce a corresponding redistribution in another, such that the electron motion becomes correlated. While the detailed theory requires a quantum mechanical explanation, the effect is frequently described as the formation of instantaneous dipole that attract each other. The magnitude of the London dispersion forces is frequently described in terms of a single Hamaker. For atoms that are located closer together, the wavelength of light interaction is instantaneous, described as non-retarded. Is quite weak. The London forces between individual atoms and molecules is why it decreases by 1 with separation as 1 by r to the power 6. This degree is the effect is cumulative over the volume of materials. Alright, so as we bulk up the materials, the effect enhances in bulk solids and liquid and decay much more slowly. The total force per unit between two bulk solids decreases by the effect is most obvious in systems that are very non-polar, such as hydrocarbons and highly symmetric molecules, or iodine. In hydrocarbons and waxes, the dispersion forces are sufficient to cause condensation, sublimation heats, liquefaction of oxygen. Right, this has no mention. This larger and heavier atoms and molecules exhibit stronger dispersion forces than the smaller and lighter, because of the polarizability of molecules with larger, more dispersed electrons. Polarizability is a measure of how easily electrons can be distributed. Large polarizability implies more easily redistributed. Same increase of dispersive attraction occurs with proton. But this is more technical now. Contribution percentage of CH3Cl with CH3Cl. Alright, so if I can see that if a molecule has these bonds, Cl, bromine, or some kind of bonds, those can. But what's so special about methanoic acid? This OH bond, methanoic acid. HCOOH. Alright, so it has oxygens, but CH4HCl. Dispersion are usually dominant. Right, methanoic acid can participate. So, diethyl ether. Alright, I think nobody has this OH form. So the polarizability is nowhere to be found in diethyl ether. I'll look at the structure of diethyl ether also. Okay, so it's a sweet smelling flammable liquid. Excuse me. Ethyl cyclopentane. It is completely formed with CH3CH5H9. So this is wound. The London force is wound and decanoic acid. Decanoic acid, capric acid, or decanoic is a fatty medium chain acid. Okay. What about methyl cyclopentane? They all are acids and CF4. Okay, the London forces is the weakest intermolecular force. As I understood that, the force called induced dipole induced attraction. Causes non-polar to condense to liquid and to freeze into solids. Because of the constant, you can temporarily develop a dipole interaction. So I guess CF4 can develop this polarizability. Such atom the balance. Okay, I can still not remember the structure of the ethyl cyclopentane. CH3CF5H9 methyl cyclopentane. So it's a CH3 group on a pentane ring. Okay, I'll remember it. But I'm not satisfied with the answers here. Despite that, it has fewer carbons, boiling point is much higher. That despite ethanoic acid can participate in hydrogen. Why is this sounds reasonable? Ethanol, as the boiling they have same molecular mass than methyl. Ethanoic has much fewer carbons. Because this will still remember. Will be still reasonable. Both are polar molecules. So this is OH. This can form dimer by hydrogen bonding, but ethanol is unable to form dimer. Therefore, the boiling point is much higher. What is dimer? Dimer and the dimer. Okay, let's read the text. Formic acid has the following structure. HCOH has a unique HCOO bond. Formic acid can interact with each other through hydrogen bonding. Each formic acid molecule has a hydrogen atom that can form a hydrogen bond with oxygen atom of another formic acid. Okay, alright, okay. HCOH. Visualizing the dimer can be represented at HCOH where two formic acids are connected. The cyclic arrangement, monomer is 1 C2H4O4. So connects with the H. Would in methanoic and decanoic acid. Methanoic. Where would you expect propanol to be placed in the between methanoic and decanoic? Between methanoic and decanoic, propanol. Propanol. It's 97. So propanol is CH3. Alright, so I guess I'll have to redo this. So boiling point is between 97 to 98, but how to figure this out without knowing the boiling point? So propan 1 all, so there's no chemical compound there. CH3, CH2, CH2OH. So it's CH3, CH2, CH2, propanol. It's pretty tough. How to determine the boiling point of organic compounds? Organic I don't want to use these things. Oh, this is better, I guess. How can you determine the boiling point of a substance? Factor which influence the compounds with similar groups, that is, belonging to the same family. Larger the molecule, longer the carbon chain, higher the boiling point. Propanoic has 5 carbon atoms. Well, that's what they asked, right? Propanol. No structure formula. CH3, CH2, CH2OH. Diethyl ether. Right. CH3, CH2, CH2OH. So the longer the chain, ethanol is C2H. Larger the molecular mass, higher the volume. A series of alcohols. Methanol is there, CH3OH. Ethanol is C2H, CH3, CH2OH. Propane 1 all. Butane. So as we increase the number, ethane, dec will have the max. Methane, di. Di has the lower one. Okay. Okay, let's read the second point. For compounds having same function, more branching, lesser the boiling point. The greater the branching, lesser the boiling point. Because more polar the molecule, the higher will be the boiling point. Alright. More the degree of hydrogen bonding. Isomer with intermolecular hydrogen bonding. Why can't they miss? Because of blindness. Excuse me. The addition of a methyl group to which carbon would not produce a side chain. I'll just try putting the question as it is. Maybe I'll get something out. I don't need any AI. How to add a methyl group to straight carbon chain? So this molecule is CH3, CH2, 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 CH3. The addition of a methyl group would not produce the same molecule. So the number of valence electrons are, there will be 6 here. 6. There are 3 ones. CH3, 4 1. Sorry. 6. Okay, what is the maximum number of propyl group? So that I know, that the benzene ring has a delocalized Charles conjugation. I have to understand how. Okay, now I'll go back to the first question where the numbering process was there. So is there a way I can get? Okay, something is happening. Let me try this. Okay. I'll add it to and then something happened here. Let me. Okay. Sure. So. Oh, sorry. I was not asked to use. So. Is there a way not to get through the Google AI? Let's use minus AI. No, I don't think so. There's a way. So. Okay, so I have no other option just to explain this image as best as possible. So, for an organic molecule having 3 rings, how to start with the labeling? So I'll go with the nomenclature and I'll get something here. The increasing number of organic identified replaced together with the fact of many compared isomers. Hydrocarbons having no double or triple bond are classified as alkanes or cycloalkanes. Although these have no functional group, they constitute the framework on which functional groups are localized in other classes and provide an ideal starting point. The alkanes and cycloalkanes are also members of a larger class called aliphatic. Do not incorporate any aromatic rings. For the compound listed in the names, a common an has been methane CH4, propane meth ethprop but 4 pent 5. Okay. Formulas and structure increase uniformly, and uniform variation is called homologous. So there's three chains all over the IUPAC. Because first we have name for simple unbranched chain, then second that we have the name for the alkyl group. Alright, that I know. So this is methyl, methyl, isopropyl, butyl, halogen, cycloalkanes have one or more rings. That's good. Now, the simplest example consists of a single unsubstituted carbon ring, and they form homologous structure series similar to the unbranched. The IUPAC names of the first 5 members of this series are given in the following. The last yellow shaded column gives the general formula for the cycloalkane. Alright, so for a mono-substituted, the ring supplies the root name and the subsequent is named. A location number is unnecessary. Mono-substituted. Okay, this is not something I want to look for. So, yeah. Fused rings. More than are common and are bicyclic, tricyclic rings or polycyclic compounds. The molecular formula that compounds have H by C ratios that decreases with the number of rings. In general, for a hydrocarbons of N carbon associated, the formula is Cn associated with M rings. For the structural relationship of rings, they may be separate. Alkane, this is the maximum hydrocarbon. Alkane, oh, alright, I forgot about that. If it's a single bond, it's alkane, alkene, alkyne. Triple bond. It's alkyne. IUPAC nomenclature rules for tricyclic rings. Excuse me. I read about the nomenclature of bicyclo, mentioning the number of carbon atoms, but then I came across a weird compound, tricyclo. What's the name of this compound? The main bridge is the bridge. Let's add this name. Excuse me. Right. So methyl 549. What is the formula for methyl 5 propyl? Okay, let's go with this. Okay, this is not what I was looking for. Now when you get to the methyl group attached to the 5th, analyze the name indicates that there is a methyl group CH3 attached to the 5th and a propyl group attached to the 5th. Evaluate the validity. I'll go back. For methyl, What would be the main chain? How is the nomenclature? For long. I would like to see. Alright, this is one thing. Open link, and I'll go with the IUPAC of organic refers to the systematic approach not found. IUPAC again organic in chemical nomenclature. The organic chemistry nomenclature. The organic chemistry nomenclature IUPAC is the method of organic chemical compounds as recommended by IUPAC. Identifying conceivable. This is not each and every object is identified by its name. It includes name of the organic such as the system. Several trivial names. Compound, a few principles. Scope of the normal IUPAC. The long chain rule. Lowest set of Lupkins. Multiple instances. Root. The word root. The number of carbon present in the longest chain. Okay. So if I'll have to go with the. So they're saying that the right way to start is epsilon 2 3 4 1 2 3 4 5 6 7 8 9. So this is seems like the longest chain here. Oh, okay. 1 2 3 4 5 6 7 8 9. Alright, so this is the longest chain. Now if I start from alpha, let's start with alpha, or let's start with beta, which I chose. 1 2 3 4 5 6. Okay, what about 1 2 3 4 5 6 7 8? So no, beta is no. Alpha, let's go with alpha. 1 2 4 5 6 7 8 9. Why not alpha? Alright. For example, meth refers to the chain with 1 and pent refers to the chain with 5. Suffix is usually a functional group. Primary is written after the word root, as in the case of alkanes. The second is just generally written after the primary. For example, compounds having alkane and alcohol group attached to them. Alkanol with an OL. X's are added prior to the root. They are useful since they indicate the presence of side chains. Primary indicate the side. Alright. There exist 9 chains with 5th carbon. But am I calculating something wrong? 1 2 6 8 5 6 7. So what difference does it make? What is delta? 1 2 3 4 5 6 7. I understand what beta and delta won't work, but why not alpha and epsilon? It's true. Okay, so these are main chains. So this is understood. So this is like 7 ethyl, 2 dimethyl, 1 and 4 propyl. So, right. So why did it start from the IUPAC is 1 2 3 4. This is the longest chain, that's why it went there. 3 1 2 3 4. Now Oh right, I think if I remember correctly, no. So where the nearest group comes out. So if I start from here, one, two, three, four, five, four. So the nearest group, like, the branching factor also matters. So the positioning should start from where the branch is the closest. So alright, so alpha and epsilon both are correct. Let's say they are the longest chains first. Now comes the grouping. One, two, three, four. The first thing will come at 4. 1, 2, 3, 4, 5. Like, I now understood that. Alright. The examples actually help. Write the structural formula. So the nearest one, that's the reason it starts from left. 2, 3 methyl. Let's see how this is done. 2 methyl, 4 dimethyl, 4 ethyl, methyl, excuse me, heptane. Now the numbering starts with the nearest one. So because it's like a benzene ring, I'll start CH2, CH2. It doesn't matter where I start from. If I would have started from here also. 1, 2, 3. 1, 3 di. Sorry, no. Propyl. 1, 2, 3. 1, 2, 3. I think this doesn't matter. Therefore, 2, 3, 3, 3 methyl. 3 methyl, 3 hexene. Why didn't 4 come? 2 pentyne, triple bond. Shouldn't something comes with respect to 4? 2 comma 3 comma 4 methyl. It should be like that, right? Alright. So I understood the naming part, I understood the bonding part. Now comes the group part. The group part states that if it should have some COH molecules or then the other kinds. I know this. Can you? So yes, there is a hydrogen. How many hydrogen atoms? It is an alkane. So how much will an alkyne be there? So it will have. I'll put this also. I did. Is there? Let's see if I get something better. I started with the. Sorry, it should have been with minus A. I guess that calculate is the operative word. Hydrogen atom. Number of carbon into 2, 6 plus 2. Let's go with alkene. Alkene. Number of alkene. By the number of alkene, we have to understand what an alkene. It has double bond. So if I have CN, H2N. So if I have, so if I have 3 atoms and there are 2 bonds, 2, 2, 4. Alright. If I have triple bond, C, 1, 2, 3, C, H, H. So it will be 2N minus 2. I guess that's the easy way. Alright. Go back. I've lost my timer. So I have 16 minutes left. Let's see. Oh, let's look at what does this side chain. I never understood what is a side chain in organic chemistry. Sorry, this is wrong again. I have to use in organic chemistry and biochemistry, a side chain is a chemical group that is attached to a co-part of the molecule called the main chain or backbone. It's an hydrocarbon branching of a molecule that is attached to a larger hydrocarbon. One factor a molecule. Which are composed of amino acids. Alright, there is a main chain, the longest chain, and then we have the side chain. Alright, so I think these. Oh, let's search what is valence electron in hetero. Sorry, I made the same mistake again. So valence electrons, it's the valence of hydrogen. Okay, so let's see. I have a molecule CH3, CH2, 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 CH3. Excuse me. Valence electron N H3 CH2 1 2 3 4. What is total number of valence in the molecule CH3 CH? Oh, alright. They don't have. Supposed to help you. I hope this doesn't lead to some video. The carbon is tetravalent. It has 4 electrons. It needs 4 more. So it has 2 electrons in the K shell. Isn't the outer the number of valence called the covalency? I think that was correct. Let's go with this. Number of valence electrons is 8. Chlorine 1. So it has, I think it's Cl minus. It gains an electron, so it has 8. So it normally has 7. Alright. Valence electron is the total number of present in the outermost shell an atom loses or gains. Carbon is 6 to 4. It has 4 in the outermost. Nitrogen has 5. Cl has 7. I was correct about that. Yes. Right. So I have 12 minutes left. I think I've covered most of the things which were. Okay, so I have this question. So let me add this question again. What's the maximum number in CH3 CH2 1 2 3 4 CH3. How many propyl groups can be added to the first CH2? Okay, I think this is too difficult. Sorry, again, mistake. What is propyl group? Let's start with that. A propyl group is alright. So it still needs just one CH. It has 2 hydrogen, 1 carbon, so this 1. So according to me, this should be. How? It has 1 2. Oh, so it has 2 hydrogens. If I replace 2 hydrogens with 2 propyl groups, it won't make a difference, right? So I actually could have answered this one. The electrons are not, they're not localized, I said delocalized. Alright, so I think I'll now go for the break for 10 minutes. I think that's what was suggested. So yeah, I'll go for the next 10 minutes. I'll go for the break, then I'll have this survey. I guess there are two surveys present there. Right, so I'll have to go to this one. By the time I'll just open this. Yeah. So let's begin this test now. I think the test is supposed to be for 20 minutes. Right, so I have this. I'll set the timer for, sorry, this is two. Alright, this is correct. And I'll expand the screen fully. Next. Okay, so this looks much more scarier than before. There are dash carbon presents in the parent chain, and it's called pentane or hexane. So the parent chain is supposed to have the largest number of carbon atoms. So if I start from here, 1, 2, 3, 4, 5, 6. This is anyway there. 1, 2. So this is 1, 2, 3. So the first bonds are coming here. I think but from alpha it will start. 1, 2, 3, 4, 5. Right. 1, 2, 3, 4, 5. 1. No, this won't be. So 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. What does the 6 comma hexane means? I understand 1, 2, 3, 4, 5, 6. It's hexane. What's 5 or 6? I'll just go with 6 hexane. I'm not sure about. Numbering will begin it. I started numbering at 1, 2, 3. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 1, 2, 3, 4, 5. Delta. I have started the numbering by because that's making the longest chain. Use this information. Answer the 5 questions. The branches at carbon X are called the branches at carbon X. One is methyl. One is C. There's CH2 already. There's CH already there. There are 2 bonds in one. So CH, and this has a single bond. So CH, and 2, CH2, CH2, and 2, CH2, 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 CH2. At the prop. I'll go with cyclo, but I'm not sure if this is the right convention. Cyclobenzene. It's not propyl, methprop. It's not propyl. There's a type of branch that is common between X and Z. So this is propyl actually. This looks like methylpropyl. This is methyl. That's common between the two of them. Which carbon is able to make another bond, X, Y, or Z? X has there 1, 2, 3, 4, no. 1, 2, 3, 4, no. Y. Yes. What is the IUPAC name of this molecule? This is going to be very tough for me, but let's give it a try. 1, 2, 3. 3 dimethyl, 3 dimethyl, 5, 6, 4 dimethyl, 4 dimethyl. Alright. Between X and Z, 2, 3, 4 methyl. I know I'm writing this as 4 methyl cyclopropyl 4, 1, 2 methyl cyclopropyl meth eth prop but pent hexane. The addition of a methyl group onto carbon would cause a change only to the name onto carbon would cause a change only to the name of the parent chain, alpha, beta, gamma. So if I add a methyl group at alpha, it won't change, and beta won't change the parent name, gamma won't change, I think delta. So well, this is actually means, I guess, where it's highly dependent from where my chain is getting started. Alright, so delta. Which of the following is not tetrafluoromethane? Doesn't sound. HCN, hydrogen cyanide. That's pretty standard for me. How many valence electrons are present in meth eth prop but? Meth is CH3. 3 means 6. CH3, CH. Alright, so CH3, CH2, CH3. So 1, 2, 3, 4, 8, 4, 3, 7, 10. No, I'm getting something wrong. Meth eth prop but. Oh, sorry. The 2 CH2, CH2, 4. It's 4 and plus 2 at prop but. CH3, CH2, CH3, CH2 at prop CH2, CH3. So there are 3 hydrogen atoms in the first one. So 3, 4, 5, 3 plus 1, 4, 8 here, 8 here, 9, 10, 11, 12, 13, 14, 15, 16. 8 here, 8 here. It is very tough. This is supposed to be simple. Right, was 23, 26. Which element has the same number of electrons as butane? That I have no idea, but I believe this won't. I'll go with iron. 26. 26 is a very large number. Okay, chromium sounds. I'll go with chromium. So chromium sounds heavy. COH last time. Alcohol sounds sweet. OH bonds. Can you answer? Yeah. Can you answer to the previous question, participant? Oxygen bonds with hydrogen. Yes. Which molecule has the highest boiling point? O O. I'll go with double O. It forms double bonds. I'm gonna need alkane. Alkene has double bonds. So I was finding that and I got it. 2n minus 2. So I know this answer. Okay, so now I have the boiling point. Which molecules have London dispersion? So there are polar molecules which have that. Ethanol has it. Ethanoic has it. Okay. And heptene has it. No, it won't have. Decane won't have it. Assume each substance which of this can ethanoic. Ethanoic is COH bond. So I think both of them, because I'm OH, I feel like it's ethanol, and COH is more like why can we? Because of London forces, I guess. London forces, despite that decane does not have a permanent, its boiling point is much higher. It does not have, decane has no boiling point. Its boiling point is much higher than ethanoic acid because of the longer chain, I guess. Decane has participated. The content oxygen decreases. Decane is unstable as its boiling point is much higher. It's unstable as a straight chain and likely to form fused structure. This sounds more reasonable. So it will form a fused structure. Where would you expect methanol to be placed? Methanol is is small chain. I'll be above ethanol. I'll place it because it's a small chain. Excuse me. The addition of a methyl group to which carbon would not produce a molecule with a side chain. All of them. It's like a conjugation process. So everybody is sharing a hydrogen bond. So the placement won't matter. The placement won't matter. The addition of a methyl would produce the same molecule. Carbon would not produce a molecule with a side chain. All of them. The addition of methyl to which carbon would produce the same molecule. Alpha and beta. If I add a methyl, where would it produce the same molecules? I guess all of them. So how many valence electrons are there? CH2, 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 CH2. So yeah, everybody has CH2. So there are 1, 2, 3, 4, 5, 20, 20. Okay, 20, 1, 2, 4, 5, 6, 7, 8, 9, 10, 30. What is the maximum number of propyl meth prop? C3H5 can be added to carbon alpha. If I add 1, 2, none. Meth prop has 3. So according to me, none. Excuse me. The electrons are not fixed, they are dispersed. What was the word? The conjugated, they are delocalized. Yes. An acidic flavor compound has been discovered. It's naturally dissolved in an organic solvent, that is, it is non-polar. It doesn't have any natural order. In lab, we are presented with 5 vials. An acidic. How will you attempt to it's non-polar, does not have, so it will be neutralized. HCl will decrease the pH. No, how will that decrease the pH? It's because it presents nitrate. It's non-polar. Oh, but it's non-polar, right? add orange and acetic. I'll believe add water. It is non-polar, so titrating with NaOH won't help. Alright, so I'll stop my timer now. Okay, stop this. Sorry, this is the timer. Right, and I'll give the score. That's bad. I was expecting more, but alright. So there are 5 carbons. Oh, why? 1, 2. I misunderstood that then. 4, 5, 2, 3, 4, 5, 6. 2 cyclopyl. And this is supposed to. The addition of a methyl group. This is. Which element has this? I was correct before. Alright. Okay, this is. I didn't know. No, there are oxygen atoms, they're not bonded. They're bonded to any hydrogen atoms. Oh, because I understood the molecule wrong. Which molecule will have the highest boiling point? C double bond OH. Okay, how many hydrogen doesn't? Oh, that's alkyne. This I knew this one. So this London process was never clear to me. Decane is unstable, contains the most. Yeah, performed better than before. The number of propyl. Okay. This is the spelling mistake. I won't add water, titrate. But the molecule is non-polar. Alright. So yes, now I have to submit some review, I guess. I'll just okay, the review part I guess I can take. Now this is I guess I have to find the review part from okay, so I have to look for so I cannot find any review from here, so I'll turn off the video now.